In this video, we have another problem related to the definition of the derivative. So that's not using any kind of fancy rules, that's just using the fact that f prime of x is equal to the limit of f of x plus h minus f of x all over h, and we're taking the limit as h goes to 0. And you can see that this form right here is very similar to m equals y1 minus y2 all over x1 minus x2, except for every y, you're making it an f of x, and you're making y1 f of x plus h. So in the denominator here, you'd be subtracting x plus h minus x, and that just gives you h. So you can see this is very similar to just the definition of a slope, except you're taking the limit as h gets infinitely small, and that gives you the instantaneous slope at a specific point, x. So we're going to be using this definition in order to find the derivative of x squared minus 2x plus 1, and we're finding that derivative at x naught. Okay, so I know that f of x is equal to x squared minus 2x plus 1. So I'm going to write out this limit here, limit as h goes to 0. I'm going to just skip the beginning part here, just go to the end. I'm saying minus x squared minus 2x plus 1. All I did here was stick f of x into the equation where it's supposed to be. All this is going to be over h. Okay, now for the beginning part here, f of x plus h. In other words, I'm using f of x, but I'm putting x plus h in for every single x in here. Okay, so that becomes x plus h squared minus 2x plus h, and just a plus 1 on the end. So now if I were to solve this limit, what I would normally do is just try direct substitution, because that's going to be the easiest. As you can see, if I were to put in a 0 for every h, I'm definitely going to get 0 on the denominator. In the numerator, this just turns out to be f of x minus f of x if h is 0. And f of x minus f of x is 0. So this gives me 0 over 0, which is an indeterminate form. So you can't evaluate this with direct substitution. I need to manipulate it somehow using algebra or something else. I need to manipulate it so that I don't get 0 over 0, because that's an indeterminate form. So that's what my goal is, and I'm just going to use algebra, use distributive property and FOIL and stuff just to try to break this down and see if I can get it into some value other than 0 over 0. So limit as h approaches 0, I'm going to use FOIL up here. So that's x squared plus 2xh plus h squared. Then I'm going to use the distributive property right here, distribute the negative 2 to each of those terms. Then we're adding 1 after that. And then I'm going to distribute the negative into this whole parentheses mess over here. So it becomes negative x squared plus 2x minus 1. That's all over h. So now what's going to happen in this next step is a ton of stuff is going to cancel in the numerator. So instead of writing it out as a separate step, I'm just going to cross them out as I realize that they cancel. So already I can see there's an x squared here and a negative x squared. So that cancels with that. We have a negative 2x and a 2x here. Those are going to cancel. Then we have a plus 1 and a negative 1. Those cancel. I think that's everything that cancels. So now I write out the next step. I'm just going to rewrite what I have written already, except for without all the scribbles. And as you can see, this should be an h, not an x. As you can see, you have h's in every term in the numerator and an h in the denominator. So there's an h in the numerator and denominator, a factor of h. So those two factors will cancel. And you're left with this. 2x plus just 1h minus 2 all over 1, which you don't even need to write. Now you can see how if I do attempt direct substitution, and then for h, let's say I put 0, okay, I didn't even have to put 0 in because it's 0, and this becomes 2x minus 2. So that is the derivative, that is f prime of x. But I'm looking for f prime at x naught. That just means that for every x, I just stick in x naught. So this turns out to be 2x naught minus 2. And that's going to be the final answer. So you can see as I did the limit, for every step of the limit, if I were to stick 0 in, I would still end up getting 0 over 0. And it takes all the way up until this step where everything has added and subtracted and canceled with this big step right here. It takes all the way up until then before I can divide by h on the top and bottom and cancel out that factor of h. And as soon as I do that, now that h is added to the denominator, I can just actually use direct substitution, and I end up getting a final result that is not 0 over 0. And that means that I did everything right as long as the algebra is correct.